So I just wanted to do another quick tutorial on a problem here on HackerRank website. Um, Basically, we're going to be trying to improve the running time of n login, so n times login, um, which is the fastest you can get in comparison-based sorting algorithms. So as it says, Quicksort usually has a running time of n login, but there's an algorithm that can sort even faster. In general, this is not possible. Most sorting algorithms are comparison sorts. So that means they sort a list just by comparing the elements from one to another. So checking if one is greater than another, and that's how you sort them. But that's a lot of comparisons in some algorithms. So a comparison sort algorithm cannot beat this running time, which is n log n. So worst case running time, n log n represents minimum number of comparisons needed to know where to place each element. And it gives you a PDF if you want to check that. And here's gives you an alternative option to your sorting. It says another sorting method, the counting sort, does not require comparison. Instead, you create an integer array whose index range covers the entire range of values in your array to sort. So, from the items that you're sorting, you get the smallest value and the greatest value. And then that's going to be your array size, your array size where you're going to do something like this. So each time a value occurs in the array, you can increment the counter at index. At the end, run through your counting array, printing the value of each non-zero valued index that number of times. So, for example, given this array here, and the smallest is 1, the greatest is 3. So your range is from 1 to 3. So 0, 1, 2, 3, including 0. Um, and this will be your result because you have at the end 3 ones, which is correct. You have 1, 2, and 1, 3, and 0 zeros. So this is essentially a frequency array. And that's what we're supposed to return. So this is expecting you to return a vector type here. Okay. So we don't have to actually sort these because it tells you it's going to be from the range 0 to 100. Um, Always return a frequency array with 100 elements. And it tells you it's always going to be from 0 to 100. Yeah. So including 0, actually it's 0 to 99. Okay, great. All right. So we're going to go ahead and iterate through this vector array and we're going to compare. Okay, so I guess we need to create another vector array. Same type, same data type. It's going to be, I'll just call it a result. And yep, that's it. We don't need anything else really. Okay, actually, we do need to pre-fill it with 100 items, and they're all going to be initialized to 0. Yeah, because that's what we're told we need. We need something with 100 items, and they're all 0. So that gives us a range from 0 to 99, which is 100, because 1 plus 99, and then plus the 0, which is an index. It's not adding the 0, it's just an index. That gives us 100 items, because from 0 to 99, it's 100 numbers. 0 is a number, 1's a number, 2's a number. Each one is one number, so it's 100 items. Um, and here we're just gonna use result and say push back the actual element that we're pushing back in there. Actually, we're not pushing back anything. That would be incorrect. So we need to create an if statement in here. So at x, we're gonna increment our counter, so it's 0. When we it'll go to yeah. Actually, I think it'll be easier if I just do it the longer for loop until I equals 0. Then, well, since the size is always going to be 100, we can just hard code that in there. Well, just for the sake of good practice, I'm going to create a size variable. And we can just use that instead of hard coding 100. Great. Yeah, that should be fine. I now realize that it would have been easier to do it with my initial for loop, but I'll just do this one. So result at the actual element. So array at I. Um, yeah. Okay. So at that element, we're just going to increment. And that should basically do it, honestly. Result is going to be returned. Return the result. And let's hope that's correct. All right. So yeah, it looks like it worked. Here's our test cases to prove it. Let's try against more tests. Okay, it looks like it failed some of them. Okay. Hmm. Oh, it gave us 1,000 integers, but they're all within the range 0 to 99. I think that's gonna be the issue. Mm-mm. Actually, it's no, and it's a good thing that I didn't hard code the 100 there for that reason. It's actually a very good practice. Hmm. Okay, I definitely see the issue. So I accidentally got the size of the result instead of the array, the actual array that contains for example, the 1,000. So out of these 1,000, I'm only getting 100. Yeah. Now it should work. Alrighty. So it looks like it passed all these tests. So we're good. So this one was just creating a frequency array, which is faster sorting than trying to sort with something like merge sort. And it's a lot simpler. If you've ever tried hard uh, coding merge sort, it can be hard, um, especially the first time you try it. But this is a lot simpler and it's also faster. Again, thank you for your time.